This lecture examines a factorial ANOVA with a significant interaction. Recall that when we looked at a non-significant interaction, we went down the left side of the flow chart. Now we're going to go down the right side of the flow chart. As we go down the right side of the flow chart, we include the following steps. We analyze the model assumptions, we determine the interaction effect, we plot the interaction, we analyze simple effects, then we look at effect size for each simple effect, and then we perform post hoc analyses and Cohen's d's when necessary. So just like in the first case, we look at the model assumptions and we notice that we did meet the normality assumption for all levels of each of the independent variables. And we also met the homogeneity of variance assumption. So now we look at the interaction effect. And as we look at the interaction effect, we do see a significant interaction. Notice p is less than 0.01. We definitely have a significant interaction. When we graph it, we can see that's what's going on with males across note-taking methods is very different than what's going on with females across note-taking methods. Notice that note-taking method 1 and note-taking method 2, there was not much of a difference for males. But for females, we see a much larger difference between method 1 and method 2. So because we have a significant interaction, we can't look at just gender and method because what's going on with males across note-taking methods is different than what's going on with females. So we input some SPSS coding, which I show you up here on the top. We put the dependent variable and we type in by, and then we put the name of each of the independent variables. And then we ask it to run an analysis. And we, again, put in the independent variable names, and we ask it to make a comparison by method, and I'll show you what that looks like in a minute. So notice here that as we compare by method, we're looking at how males did across each method and how females did across each method. Notice for males there was not a statistically significant difference in note-taking method. Let's go back and take a look. Notice that males performed relatively similarly, 0.2 and a 0.35. There was not much difference here. But for females, we see a much larger difference, about 0.18, and then here we have about 0.65 or 66. So we can see a large difference happening for females. So that's what we see, no significant difference for males, but a significant difference for females. And then once we identify that we have a statistically significant difference for females, we can look at our descriptive statistics for males and notice that here are the mean differences for males, or the mean values at each level for the males, and the mean values for each level of the females as well. And here's the grand mean. So you can see here's for females in the grand mean. And then because only women were significant, we're only going to look at the values for women. We don't need to run a post hoc analysis for men because there was no statistically significant difference in males. But there was a statistically significant difference for females. So we can look at a post hoc analysis and we can see that between method 1 and method 2 for females it was significant, as well as between method 2 and control group it was significant. But it was not significant between method 1 and the control group.